Hi everyone and welcome back to STEAM Week. We are going to be looking at a very exciting challenge today, aren't we, Miss Shuttleworth?
Yes, we are. We've got a really exciting engineering challenge for you.
So we're going to be looking at solar ovens today, and to start off we're going to be looking at a bit of background knowledge to get us started. So the first thing that we're going to look at is a conductor of heat. Now, a conductor of heat is a material that allows heat to flow through it easily. A good material which conducts heat is metal. Knowing this is extremely important because it helps us within our homes, for example, with cooking. If we use the metal pan on a stove, the metal will conduct heat, making the pan hot, therefore cooking the food. And I want you now to go and see if you can find some good conductors of heat in your home and see if you can list them. Miss Shuttleworth, do you want to talk about what an insulator is?
Okay, so an insulator of heat is basically the opposite of a conductor. So there are some materials that do not allow heat to pass through them, and this makes them bad conductors of heat and therefore an insulator. So these materials are useful within our home because they can help us keep objects warm and prevent us from hurting ourselves. For example, when you're cooking your food in your metal pan, you will notice that the handle is made out of rubber. So the rubber is a good insulator, which means that the heat in the pan doesn't heat up the handle and then doesn't burn your hand. And so after you found all your conductors, you then need to go and have a look and see if you can find any insulators. We've just given you a good one, find a pan. And then see if you can find anything else that you think won't allow heat to travel through it.
Yeah, I'm sure there'll be lots of good things that you'll be able to find in your home as well. The last thing we're going to look at is a reflector of heat. Now, a reflector of heat is a material which does not absorb heat. So instead, the heat reflects or bounces off it and can be redirected somewhere else. The best type of materials for this are shiny. So once you've found your conductor and your insulator, I want you to see if you can go and find any good reflectors of heat in your home. Remember, they are materials that are shiny.
So these are all the things that we are going to need for our task today.
Do you want to talk through it, Miss Shuttleworth?
Yes, of course. So we are going to have a go at creating a solar oven, okay, which will allow us to get a better understanding of conductors and insulators, absorption of heat and reflection. So our solar oven, you get the idea from solar that it uses the sun. So it doesn't use electricity like a normal oven. We're going to try and use the power of the sun to create something that cooks.
So what we're going to do now is you are going to have a look at this YouTube video, and this will give you a little bit of background knowledge as to why solar ovens are so important. Next, we're going to have a look at how a solar oven works. So as you can see on the side, there is a diagram of a solar oven, and this is what we're going to try and recreate a bit later. Now, a solar oven works because it is designed to absorb more heat than it releases, so it keeps the heat inside the box. The sun rays are reflected off the lid, so off of the shiny material, and directed into the solar oven to again create all that heat inside the box. This heat is then absorbed by the materials within the solar oven that act as the conductors. Once the heat has been redirected into the solar oven, it is then trapped by different materials that are good insulators. For example, the plastic. This stops the heat from going out, and it stays inside the solar oven, making it extremely hot and therefore cooking the food that's inside.
Okay, so once you have gone through making this solar oven, there are some key questions I want you to think about while we're working through it. So, what colour would make a better insulator and why? So you'll be able to understand that once we've had a look at what we're going to use to make our solar oven. What materials have we used that are good conductors, and what does a conductor do? What materials have we used that are insulators, and what does the insulator do? And what materials have we used that are reflectors, and what does a reflector do? So those are just some key questions to have a think about while we go through the process of making our solar ovens. Okay, and then we've got sort of a debate between me and Miss Addison here. So I think that a black material would make a better conductor because I think the dark colour will absorb the most heat, whereas Miss Addison thinks white material would be a better conductor because she thinks the light colour will absorb the most heat. Okay, so while we're working through this, I want you to think about who do you agree with and why.
Oh, Miss Shuttleworth, with missed punctuation on this slide. I wonder if the children will be able to find out where it is.
They can have a look. That's their extra challenge.
Yeah. Okay, so for your experiment, you will need a nice sunny day, and we are lucky today, Miss Shuttleworth, because it is nice and sunny outside. You're going to need 2 different sized cardboard boxes, tin foil, clean film, dark or black paper, and then paper, newspaper or bubble wrap, sellotape or glue, and an egg. Hi everyone, we are back and we are going to show you how to make a solar oven. Now, you know we said it was nice and sunny outside, it seems to have gone in, so we are currently sitting in our coats, aren't we, Miss Shuttleworth?
It is a bit chilly, and I've also got children and a dog running around in the background, so if there is extra noise, I apologise.
Okay, speak us through it then, Miss Shuttleworth.
Okay, so from the list we gave you, you should have a little box, a larger box, okay, and then we'll talk you through the rest in a minute. That's what you need to start with, okay? So, first of all, with your little box, you need to line it with something that is going to be a good conductor of heat. Now, I have argued that the darker the colour, the more it is going to absorb. So I wanted black paper, but I can't find any. So I've now found a black bin bag, which I am going to line the inside of my box with.
And I thought that the white colour would be better. So I've got a white paper and I'm going to line the inside of my box with white paper.
Okay, so we're just going to do that and then we'll be back with you.
And white inside.
You're white inside. Okay, hang on, one more bit of tape. Okay, I've made the inside black. Right, now, with your smaller box, you are now going to place it in the middle of your larger box. I feel like my oven's bigger than yours, Miss Addison.
I have to say mine is quite sizable.
Okay, so that should be in the middle. Now, around the edge, I don't think you can see that very well, but that's fine. Around the edge of the smaller box, you are going to put your insulating material. So that could be newspaper, paper, bubble wrap. I've got packaging paper that came out of the Amazon delivery box. So you're going to rip that into little pieces. And you're going to stuff it all the way around your smaller box.
I've just got plain white paper that I'm going to scrunch up. I have to stand up for this.
I know, you can't actually see my head now. Right, so you're trying to stuff it as close as possible and almost fill it to the top of your smaller box. We want to try and insulate as much heat in our oven as our eggs.
Nearly there.
Okay, I'm done. Insulated all around.
Okay, can you see the inside of mine, Miss Shuttleworth? Does that look about right?
Yeah, looks good. Insulated around. Okay, so next thing you need to do is you need to create a lid for your box. Now this needs to be as airtight as possible to again stop heat escaping. So this is my lid, and we're going to have to cut a hole out of our lid to put the plastic over, because obviously if we just have a lid on, the sun is not going to go through and cook our egg. Right, I have created a lid for my box with plastic along the hole.
I have cheated slightly because I have found an actual lid because I didn't have the materials. So we're going with this.
Okay, that's fine. We can improvise. The children will probably have to do that as well, so that's fine. Right, so the lid will obviously fit onto your bigger box and make sure all the heat stays in. Now, we don't want to put the lid on just yet because obviously the egg's not in there yet. So the next thing you will need is your reflective flap. Okay, so now Miss Addison's got one attached to her box. I've made one, and you are going to cover that flap in aluminum foil. Okay, because remember we said any shiny material is going to be a very good reflector of heat. Shiny flap.
Yeah.
Right, now I'm going to attach that to my lid.
Mine's got a bit of a hole in, but again, improvisation is key at this point.
You
are so okay. I'm partly tinfoiled.
Right. There you go. Okay. Tinfoil flap. Right. Now, what we are going to attempt to cook is an egg. So this is Miss Shuttleworth's egg.
This is Miss Addison's egg. Mine's called Shelley.
Okay. Very nice. Now, you are going to place your egg in the middle of your oven.
Then you're going to put the lid.
You're going to put the lid on and make sure it is tight. You might want to sellotape the lid to make sure that it is airtight. I will probably sellotape my lid. And then you are going to place your oven somewhere in direct sunlight and position the reflective flap to make sure that the sunlight is shining into your oven. Now, you may need to use a pencil or a stick or something to prop your reflective flap into the correct position, but it will depend on where you put your solar oven. You are then going to leave it in the sunshine for a couple of hours. You may need to move it around a bit, obviously, if the sun moves. There's no point leaving it in the shade because it won't do anything. And then after a few hours, Miss Addison and I will check on our eggs and see whose has cooked the best and whether dark material or light material has worked most effectively.
I can't wait to see the results, Miss Shuttleworth.
I'm quietly confident here.
Same, so am I. Right, shall we check back in a little bit then, and
yes.
We will hopefully come back with some hard-boiled eggs.
Hopefully.
Fingers crossed. See you later.
Bye, guys. Bye.
Okay, so we are now back. We've left our eggs outside for a couple of hours and we're going to have a look at the results, aren't we, Miss Shuttleworth?
Yeah, we are.
Okay, so I've got my oven here and I'm going to get Shelley out of it.
I'm going to get mini Miss Shuttleworth. I can't get in. Hang on.
I really hope it's cooked.
Let's go this way. There we go. Right,
because remember, we're also having a look, aren't we? We're having a look at the difference to see if the best insulator is black or white. Okay,
right.
Shall I go first?
Okay, so we're going to test them by smashing them.
I'm going to put a little dish underneath because I don't want it to go everywhere if it hasn't worked. I'm just going to point the camera down a bit so you can see what I'm doing.
Okay, hang on, my helper's gone to get a bowl.
Please excuse my dirty table, I haven't cleaned it. Okay, ready?
Yeah, I'm ready.
Come on, Shelley. Oh no!
Oh no! Kitchen
It hasn't worked! Look! So, obviously, the white colour is not a good insulator.
Okay, right, let's test the black. You ready? Okay. Bye-bye, Miss Shuttleworth. Oh!
It's an egg!
Woo!
It's a little cooked!
Brilliant. So, Miss Shuttleworth, what does that tell us about the black colour?
That tells us that the black is the best insulator of heat. So it absorbed all the heat of the sunshine, and it meant that my egg cooks better than your little white one.
Okay, we cannot wait to see your results. So please, can you make sure that you post them on Twitter, because we're going to be having a look through, aren't we, Miss Shuttleworth, to see how your eggs do. Yeah. Okay. See you later.
Bye, guys.